Hey guys, today we're learning about scale drawings for 7.7. 7.7 we're learning about. So a scale drawing is a two-dimensional figure that accurately represents an object. That scale figure is mathematically similar to the object. So you guys have to remember what the similar means. Similar means it's the same shape but different dimensions, okay? So when we're talking about same shape, we're talking about like this, but different dimensions. So if this is 1, 1, 1, this might be 3, 3, 3. These are similar figures. So a scale drawing is something like this, okay? A scale gives the ratio of dimensions in the drawing to the dimensions of the object. So a scale gives the ratio of the dimensions in the drawing to the dimensions of the object. All dimensions are reduced or enlarged using the same scale. Scales can use the same units or they can use different units. Now, the one thing we need to know is that when you read a scale, the scale is read A to B. A to B. So for instance, when we read this, what they have here, this is going to be read as 1 centimeter to 3 feet. So this scale right here is 1 unit to 20 units. This one is 1 centimeter to 1 meter. This one's 1/4 of an inch to 1 feet of an inch. So here's our first example. Write this down, example 1. Example 1, using proportions to find unknown scale lengths or a scale or length. So remember, a proportion is something that comes out to be equal, or I should say two ratios that come out to equal. Remember, to find proportions, we do 1 times 6 to get, and 3 times 2. So this would be a proportion. So let's read example A. Example A says the length of an object on a scale drawing is 5 centimeters, and its actual length is 15 meters. The scale is 1 centimeter to 1 meter to blank meters. What is the scale? So we have an object and the scale is 5 centimeters to 15 meters. We also know that the scale is 1 centimeter to blank amount of meters. So to set up the proportion, what we're going to do is we're going to do 5 over 15 and 1 over m. Okay, so it's going to be 5 over 15 is equal to 1 over m. We don't know what this m is. Let's call it x. Okay, now you remember, notice here that these units stay the same. So centimeters are on the top, then centimeters has to stay on the top. And if meters are on the bottom, then meters have to stay on the bottom. So now we have to do cross products. So 5 times x is equal to 15 times 1. So we have 5x is equal to 15 divided by 5, and x is equal to 3 meters. So the scale would be 3 meters. For the second one, we have the length of an object of a scale drawing is 3.5 inches. The scale is 1 inch to 12 feet. What is the length of the actual object? So we have an object that's 3.5 inches over x amounts of feet, and that's equal to 1 inch over 12 feet. So again, we're going to do cross product. So 12 times 3.5 is equal to 1 times x. And then 12 times 3.5 is going to get us 42. So x is equal to 42 feet. So the actual object is 42 feet. Now, a scale drawing that is smaller than the actual object is called a reduction. Okay, so it's smaller than the actual object. And a scale drawing that's larger than the object is called an enlargement. So make sure you guys write those down. So this is a life science application. Under a microscope, a 1000:1 microscope view, a paramecium appears to have a length of 39 millimeters. What is its actual length? So we know that the scale is 1000:1. And it appears to have a length of 39. Now, it appears to have a length of 39, so the 39 millimeters is going to go on top because this is how much it's zoomed. This is the original. So we want to know what does it look like. Okay, so the original is X, and when it's zoomed in, it looks like it's a 39. So we're going to do 1000 times X is equal to 39 times 1. Divide by 1000. So X is equal to 0.039 millimeters. So we know it's going to get smaller. Okay, 0.039. So you always have to ask when you set up these proportions, is this the zoom or the enlargement or the reduction? Then the enlargement and reduction needs to go on the other side. So you guys have to read these carefully. Okay, so when we read 1000 to 1, we have to know, okay, 1's the original and it gets zoomed in 1000. And then it says it appears to have, and that appears gives us a clue that this is what it actually looks like. So we want to find out what the real size is. Okay, last one. We're going to use scale drawings and scales to find heights. So example 1, letter A says, or example 3, letter A says, if a wall in a 1/4 inch scale drawing is 3 inches tall, how tall is the actual wall? Okay, so the scale drawing is 1/4 inch. Okay, and then in real life, the scale is 3 inches tall. So first, the scale is 0.25 inches. And we know that a wall cannot be in inches, right? There's no wall that's in inches because that's too small of a unit. So it's going to be under 1 feet. That's going to be our scale. And that's going to be equal to, they say the 1/4 inch is 3 inches in real height. That's the scale. So we're going to try to find out X feet. So this is the real height. And up here is the scale. Okay. So 0.25 inches to 1 feet. So basically 0.25 inches is equal to 1 feet. And the scale is actually 3 feet. And we want to figure out what the actual scale would become. So it's going to be 0.25x is equal to 1 times 3. Divide by 0.25. And you get x is equal to 12 feet. So the actual wall is going to be 12 feet tall, which makes sense, right? That's an appropriate length for a wall. Now, how tall is the wall if a 1/2 inch scale is used? So the scale is 1/2 inch, so 0.5 inches over 1 feet. And it's the same thing, 3 inches to X amounts of feet. So now we're going to do 0.5x is equal to 3 times 1. Divide by 0.5, and so x is equal to 6 feet. All right. So for these scales, we have to always make sure, okay, what is our scale? And then what is the actual height? And you have to match those up. All right, bring your questions tomorrow if you guys have any. Make sure you guys do your exercise tonight as well. All right, guys, have a good night.